All right, for the second set of questions, the first one asks us about the mystery raster. And in our contents pane, you can see we just have the one raster here, and it's called mystery. And so we really don't know. We've got a range of values from 0 to 82 approximately, but without looking at this, there's really no way to know what it is. So I would recommend turning it on and zooming to it. And you can see we are just east of Salt Lake City. If we turn off the mystery raster, you can see we're in the Uinta Mountains. And so let's zoom in a little bit and see how this raster layer overlays with the base map. So we can see that there's some pretty defined ridge lines and a bunch of lakes. So let's turn this back on. And it looks like the high values are just below the ridge lines, and the ridge lines themselves have really low values. So let's just sample the values. So if we click kind of at the top here, we've got a mystery value of 31. And as I go down the slope, 67, yikes. 60, 40, 42, 29. The dark are 13, and if I go to some place that looks really dark, it's actually 0. So let's look and see what that looks like on the map. I clicked right here, and that's Upper Red Castle Lake. So when I clicked on the lake, the value went to 0. This is a pretty good indication that this might represent slope. Remember, from elevation, we can calculate slope in degrees or in percent. We can calculate aspect, curvature, and hillshade. So those are the most common. We know this isn't elevation because nowhere in the Rocky Mountains do we have sea level. Curvature typically has whatever the max value is, kind of has an equal and opposite negative value. So we'd expect to see, negative 70, 80, 90, and we don't. Let's see here. Hillshade has a range of values of 0 to 254 shades of gray. Aspect has a range from 0 to 360 because they're cardinal directions. And so we're really left with slope. Slope in degrees would have a range of values from 0 to 90, so that's pretty realistic here. Percent, in a mountain area, I expect to see percent slopes up in the 5, 6, 700% because a 45-degree slope is the same as a 100% slope. 45 degrees means your rise is equal to your run. So dividing them gives you 1, multiply it by 100, and you get 100%. So 45 degrees is the same as 100%. And in this kind of a mountain area where we have really steep slopes, I would expect to see values well above 100. So I'm going to guess that this is a slope raster calculated in degrees. How could you verify? I would probably just download a slope layer for this region or an elevation and calculate the slope myself just to verify. But that's the kind of thinking that I would go through. All right. Are there more Starbucks in Michigan, Illinois, or Pennsylvania? So let's look at those two data sets. I think that's always a good place to start. So Starbucks and states of the US. I'm going to zoom to that. All right. So we're just talking about the contiguous US. And we basically, to answer this question, we need to know how many Starbucks there are in Michigan, Illinois, and Pennsylvania. And so we could look at the Starbucks layer and see maybe there's a state field. Oh, there is. So we could do something funny here. We could do like a select by attribute maybe. And we want to know where the state is equal to Illinois. Let's pick a point in, let's see, what do we have here? O'Fallon, state, it says US, country US. So that is not a helpful field. Uh-oh, what are we going to do? Turns out we can't use the attribute table then, unless we have something else. I love that it's got the open hours, but it doesn't tell us what state it's in. So how else can we figure out how many points are intersecting each state boundary? Let's try Googling it. And I usually type in ArcGIS Pro, how to get a count of points within, whoops, oh my goodness, within polygon. Counting points within a polygon feature, that sure looks good. Let's see if we can just scroll until we find the tool name. How to count the number of point features within in the Summarize Within window. Ooh, I like the sound of that. Let's see if we can find Summarize Within. I'm going to go to the geoprocessing. Summarize Within. There it is. Oh, we should probably read to see what it does. It says it overlays a polygon layer with another layer to summarize the number of points, lengths of lines, or ... within each polygon. Yeah, that's exactly what we want. I clicked on the wrong one. So our input polygons are going to be our states, because those are the polygons. We want our Starbucks points to be the features that are summarized or counted. And I'm going to leave this for convenience and run it. Now it is going to create a new output file for me, and you can see it just popped up over here. Summarize Within completed. We got the go ahead. So here's the original and here's the new one. They look the exact same. But if we go into the attribute table of our new output, we can see all the same fields. And then at the very end, count of points. That's handy. So let's just see, how can we test to see if this is right? If we sort it ascending, we have a state with only 4, Vermont. So let's cruise up there and see if we can. If we can verify that there are exactly 4, and it sure looks like it. Okay, so there's 4 there. There's 9 in North Dakota. We could verify that. Our highest, California, has 2,043. That kind of makes sense. So, I mean, that's how I would go ahead and verify that this worked, I guess. And so now what we want to know is just which one has the highest. And I think you could scroll through the names here, but I might just use my select tool. And we know that we want Michigan. Oh, sorry, Michigan. Hello, there we go. Michigan, and who else was it? Boop-a-doop. Illinois or Pennsylvania. Make that a little lower. Here's Pennsylvania. I'm just going to, all right, Shift, select. I'm not working with a mouse. All right, and Illinois. And Shift. Okay, so right now it should only be showing the 3 of the 49. And so I can go back here. That took longer than it needed to. Michigan, Pennsylvania, Illinois, counts are over here. So 388, Illinois is the winner. And that's where these numbers came from. That wasn't very smooth, but that's GIS. All right, I'm going to clear my selections so I don't mess anything up. And we're going to find out how many nuclear facilities are located in seismic hazard zones with an AcVal probability of greater than 50% G. All right, how are we going to do this? First of all, let's look at the data that we need. We want nuclear facilities, right? Yep, and the hazard zones, seismic hazards. All right, and so first of all, we need to find or identify the zones that have an AcVal probability greater than 50%. So I might go into the attribute table and just look at this. We already did because we were inspecting this earlier. We could do a select by attribute and select where the AcVal is greater than. So it doesn't say greater or equal to, so I guess I would leave it like this. And if we hit OK, it should select all of the polygons that have, and they're all over here on the west coast, it looks like. And so then the question is, do any of our nuclear facility points overlay these areas? And so that might be a select by location for me. So I've got a selection of polygon areas. And now if I do a select by location, my selecting features, this is how I like to read this. The thing that I'm using to do the selecting, this is my hazards layer that I just picked from. And then the features that I want to be selecting, they go up here. So this is where I would put my facilities. And intersect works because I want to count all of the facility points that intersect the selected seismic hazard polygons. And you can see here that it's warning me you've got some records selected. And that's good because that means it's only going to be selecting points that intersect those 60 records that have ACVAL greater than 50%. So I'm going to just hit OK. And then where can we find out how many points were selected just now? We would look in the facilities attribute table. And it says 0 out of 65 were selected. So none of the nuclear facility points are in seismic hazard zones with probabilities greater than 50% G. That's really good news, isn't it? So that's where we got the 0 there. And that's the thought process behind the analysis. All right, hang tight for part 3.